Okay, back to this thing, which is the 4011 NAND gate stuff. So this is not what I was intending to do, but I just thought I'd do it for the fun of it. So this is what we had from last time. So you can switch the LEDs around, and that works all good. And so I made this circuit here with this reset set flip-flop thing. I shouldn't have done that little line over the top because they're not really working that way. But we're going to go through it a bit more. But I thought maybe I would try and make an interesting circuit out of this one little IC. Make it do something useful. This doesn't really do anything useful other than change the LED backwards and forwards. So we're going to use all gates on this one 4011. I don't know if this is going to work, so we're just going to find out. Well, I'm going to try and make a random coin tossing circuit so that it will alternatively choose between, well, not alternatively, but it will randomly choose between one LED or the other one, so red or green. And how do I intend to do this? Just using the 14011. So this is the circuit that I came up with, and it didn't draw very well. So I don't know how well this is going to work. So we're probably going to have to make this a bit better later on. But we're going to make this the most ridiculous oscillator in the world. So when we have it wired like this, so this is my NAND gate here. And these are the two inputs, but we've wired them together, and they're wired so the output here, they're going to be reading the output voltage from the oscillator. So if the input is low, the output will be high, and that will go into here, and then the input will be high, and then the output will be low, and it will go around alternating between these two states as fast as the IC can go. So normally this is not a very good oscillator. You can't control how fast it goes. It will probably vary on the quality of the IC, and it will probably produce an oscillation. I'm going to draw it, which looks something like this, right? It's not going to look, I don't know if that's going to show up on the camera, but it's not going to be a nice square wave. It's going to be some kind of rubbishy, not quite getting there, like I suspect, I don't know. We are going to try and find out what the frequency of the oscillation is at a later point, not using an oscilloscope that can actually check that out. So on a decent oscilloscope, I'm sure we'd be able to see some rubbish here. I don't know why I think that. I'm just pretty sure that's what it's going to look like. But that's the whole point, is this is going to be going high, low, and it doesn't matter how fast it goes, just as long as it goes, you know, really, really fast in comparison to the human eye. So what I wanted to do is I want it to be quickly changing between two states, and then when you do something, it will stop and look at one of those states. And so this is what the rest of the circuit is for. So over on this side here, we've got this RS latch thing that we made before with the reset and the set. But basically you can look at it that if you put this one high, this one goes on. If this is high and this is low, then this comes on and that one goes off. If this is high and that one is low, then this one comes off. And if they're both low, then it keeps the current state of what it was before. And if they're both high, that's an illegal state. But as you can see, we're not going to have them both. If they're both high, they both go on, as we discovered in the last video or two. So we don't have to worry about that though, as you're going to see. So what's going to happen here is the output of this is going to go first into, I think I've drawn this slightly wrong, which is a shame. Oh, it's not going to work, is it? I didn't think about that. We're going to have to throw in some diodes or something. Yeah, we will, won't we? So I think this is going to need a couple of diodes over here, because I don't know why I thought that was going to work. But the idea was, so just pretend we ignore this for now. So I'm going to have to color over that line. Why did I think that was going to work? Because I've gone and linked these two things together, and if you do that, then it's just not going to happen. I guess because this is what you do when you don't make enough circuits. So just forget this whole bit here. And we'll come back to it in a second. So what's going to happen here is this is going to go through here, and if this is high, this is going to be a high into this part of the, so if you imagine this is the reset thing, if this output here is high, it's going to go through here. There's going to be a pull resistor. I'm just going to call it a pull resistor because it's going to pull it in whatever way it currently is. Let me just say it's a pull-up resistor for now. So it's going to pull this up to be positive. So it's going to put a high voltage here, and that's going to turn that one on. And at the same time, if it's high, it's going to go into this bit here, which is an inverter. So again, we've got two inverters here. So this one's inverting the signal. So high going to be low, and then you're going to have a low going into here. So what you're going to get, if this is high, you're going to get high here, low here. And if this is a low, it's going to go in here, be inverted, get turned into a high. And if it goes this way, it's going to go into here, and it's going to not be inverted. So what did we have before? Low, low into here, and low. So you're going to get, if this is a low, this is a low, this is a high. And if this is a high, this is a high, and that is a low. So in both cases, they are valid states, and so they're going to switch the output backwards and forwards between here, which is kind of silly really, because you could have just, you might just say, well, I could just read it off here. But what I want to try and do is I want to be able to override this, and I don't know if this is going to work now. So this is probably a terrible video. So I don't know why I wrote this. So I thought what I was going to do is that I was going to have this little button, and when you press it down, it's going to pull it straight down to ground. So there's not going to be, so because you have these pull-up resistors, you're just going to have this being 0 volts or ground volts or low voltage here. And that's going to give a low voltage across both these things. But for some silly reason, I was half asleep when I did this last night really quickly. There's a problem, of course, is that in order to get this to work, because I have to pull both parts of these low, I'm sure there's a better way of doing this, isn't there? If I pull both parts of this low, there's a wire connecting both of these things, so the output of this is always going to kind of be high all the time, so you're only going to get a high voltage on the outside. Because if this is high, then that's going to read high. Well, actually it might not. It will probably read low because it's being pulled to that one. Well, either way, it's not going to work. So what we have to do is try to work out a cleverer way of doing this. And I think probably the best way is, so this one is going to have like a diode going here, pointing that way. And this is not going to be connected. It's going to come along here, and then there'll be another diode going to there, and I'm hoping that will work. So in this case here, you can only pull it to ground, you can't do anything else. So this will no longer be, so this bit here will not be connected to here, because it will have to go, any voltage will have to go through there, and the same with that one, any voltage will have to go through there to connect them up. So hopefully that made a bit of sense, and we'll see if it works. If it doesn't work, then that I don't know why I thought that was going to work. I guess I wasn't paying attention. Right, well, it kind of, it's the kind of thing like, because I'm still learning all this kind of stuff, and you make these kind of mistakes. You think, oh, I'll just link these two things up, and then I'll forget about the fact that I've actually linked those two things up now all the time, permanently. I mean, if I had a clever little buttons system, so you could cheat, of course. You could have two buttons, and that when you press them, or you could do something with a transistor as well, I guess. If you have two buttons and you press them at the same time, then you'll be pulling it low, and it will be latched into the current state. But then you need two buttons, or you need like a double pole, or whatever the term is, switch or button. But I want to do that, so we'll just see what happens. So I've got this bit of the circuit already still here, and I've got two left over. So the first thing we have to do is we have to make an oscillator. But I'm going to need. Actually, I don't really need it, do I? I was going to say I do. But I can't actually see it from here. I'm just going to double check that I know which way around the inputs go, but I'm pretty sure it's obvious once you get used to it. Alright, so that's the 4011 there. All I care about is which way around these things go. So the first thing is you want to make this oscillator. I'm going to turn it off. So this is going to be a very wasteful circuit. This is going to waste a lot of power doing this. Because this thing is going to be continually changing, as I said, and so as I said a couple of times, that the CMOS chips use their most power. Most of the power is used. Energy is used. I don't know what the term is, to be honest. At this time of night, what the best way of saying this is, but they're doing the most work when they're alternating between things. So when the gates are changing, then you're going to be using more power, as opposed to when they're not changing. But the rest of it's going to be used on the LED. And so this is going to look like, when it's not doing anything, it's going to look like both LEDs are on, but they're going to be alternating between each other. So just looking at this, I've got to make sure I've got this the right way around. So I'm going to turn it to the books like that, so then I can see what I'm doing. This looks like it matches up. First thing is I want to link the two inputs to be together. So the trick with this circuit, if it does work, is that you could then make it out of a 4049, which I think would be quite neat, because a 4049 circuit where you make a random coin toss circuit. So the next thing we're going to do, also in another video, is make it so it's a bit different. So at the moment, it's going to, when you're not pressing the button, it's going to be alternating, and the LEDs are both going to be on, and then when you press it, when they're going to stop. Maybe it should be the other way around. The LED should be off, and when you press it, one of them is chosen or something like this, or it alternates. Think of some way of making it slightly more efficient. But I like the idea that the LEDs are on, because you don't really want to keep the circuit on all the time, and if you don't have the LEDs on by default, you won't know it's actually doing anything. So that's not so good. So I think this will be the best and easiest way. Right, so that's actually a really simple thing. I've tied both the inputs together, and one of the inputs is going into the output. Or actually, one of the outputs going into the input, while the output and the input are connected. I don't know if you can say they go either way. So that's that one done. So that's the easy part, and then we've got to do exactly the same kind of thing. I don't have enough of the little tiny ones anymore. Oh, there we go. There's a tiny one. Oh, well, this one's okay. I've got another little packet of these, and this one's got tons of tiny ones, so we'll steal them from here. I keep buying packets of these every so often, because they are like the best things in the world. Alright, so this is going to be an inverter. So again, we're going to tie the two inputs together with these little tiny ones. And of course, you don't have to tie the inputs together. You could do something clever where you have them only tied at some point with a button, which you could do here, right? Maybe that's what I should do. Maybe why do I not do that? Why do I not have the inputs, this connection, just going through a button? Because then it wouldn't alternate, and then you'd have your output, and then it'd be like, well, you did everything you needed. You didn't even need the RS flip. Oh, that makes much more sense. But okay, too late now. We're going to do this because I've started this and I want to finish it. So what I was just saying is that if you put the button here, oh no, but then it's going to be pulled. I think I went through this idea that it has to be pulled weekly. You still got to store it somewhere. No, that's not going to work. That's not going to work. So I did hum and ha about this a lot to try and get it to work. So the two inputs are connected, and then so one part, so the input to this one comes off the output of this one here. So I've got to connect up. That will make sense. Alright, so where did I put my little pointy thing? So I don't know if you can actually see this on the video, but the output of this one, which is this pin here, is again going into the input of this, which is tied together. So now we've got the output from here, and we've got the output from here. So these two things are my alternating outputs. So now all we have to do, and I feel like I probably should use these rubbishy ones for it. These ones are looking a bit sick. Maybe try this one here. Do I have any ones that don't look sick at the moment? Because they all kind of look like they've had very bad days. They do get abused a bit. I did have some... Oh, here we go. Here's a whole pile of them. The things that I hate so much because they're just so terrible. But I still use them anyhow. They're pretty good sometimes when you just use them straight away. Like, and they haven't been used. Like these go okay. So one of these has got to go into my input. So right now I'm using these buttons. So I'm going to disconnect the buttons, I think. Alright, so I have to disconnect that wire there. Well, I don't have to. I can just take the button out for now, because that way it will be disconnected. So that's one of the inputs to there. So one of these is going to, it doesn't really matter which one it goes where. So I'm just going to put that where the button is. And that should be fine. And then I'm going to put this one also where the button is. This button is not even connected. How does that work? Oh, it is connected, right. It's so nicely done that they couldn't tell. So we're going to need one of these buttons in a second though. I've run out of space to put it. We'll have to put it right here because it's not connected up to anything here. Or I can probably put it across here. Alright, so that one's going across there. So this is going to be my button to stop thing. Now this is where it's going to get. So if I turn it on now, it should just both come on. So I don't know if it's alternating or not. But it could be. So if I take one of these out, it should do something. Was that the right way around? No, this is the right way around. So, hold on. This is going to get very confusing. Well, it actually does change the brightness. So that went dimmer. So I can assume that this is actually alternating really, really fast, and that's why it's dimmer. So they're not both on at the exact same time. They are alternating really, really fast. So now what we've got to do is do some way. So we'll just do what I was planning to do. Except we have to do one more thing. So I actually connected these up straight away. And they can't be connected up straight away. They have to be connected up via these things. So we're not using these anymore. And that's really going to stuff the whole thing up. So the pull-ups, the pull resistors that I was using, I think they were pull-ups. Yeah, the pull-ups I was using before, I don't need anymore because I don't have those. It's just changing. It's changing because the inputs are floating. So this one, we're going to go back and do what we're going to do. That one's going to be connected to the input of that. So it should just come straight on. Alright. And then we're going to connect this one. So it should go back to being half brightness or not. And now it's not working at all. So what have I done? Is it supposed to go all the way over there? I think it's... Well, I'm running the risk of touching the wires together, which is not so good. So I don't know if that was going to work because... I just have to check. So it doesn't look like it's going to work, does it? Because these are not doing what I want. So they should be on all the time. So what have I done wrong? So that one is being pulled to ground. Well, I don't think I wanted it to do that. No, that's the power one. Okay. Right, well, that's right. That's right. And I think that's right. So this is not giving me the result that I wanted. And they kind of have to. So, why? So I have to think. I have to think. Right, so this looks right. So this is the output of that one, and that one's... The output of this one is going into there, which is right. And the output of that one is going into there, which is right. And then one of them is connected to there, which is right. And then the other input... this is where I think it's... this is where I've gone wrong, isn't it? The other input's connected to there, the other input's connected to there. And that one is connected to there. And 1, 2, 3, 1, 2, 3. So I guess the problem is, so the one that's working is the one that's coming out of the buffered one. So this might be the problem, of course, is that this one is buffered and that one is not. And so that's causing a problem when it tries to read these things in. So I'm not too sure if there's anything I can do about that. Except maybe try putting some diodes in to fix it. Where did I put my big box of diodes? I probably should have got out before I started this. Where are they? Here they are. Here's a big pile. Alright. So what I'm going to do is I am going to take that one out for a second, and then I'm going to, and I have to think this through for a second. I only want it I'm just going to turn it around to see what happens. Well, that's not going to work, is it? Yeah, I think we're going to have a problem with this because I'm just going to ruin my whole oscillator by putting something in there, and without buffering it, it's just not going to work, is it? So, well, let's just imagine if I put a diode here. So this is high voltage coming out of here, and we can say this is like pulling it to ground. What's it going to read? It's going to still read a high voltage. And then if that's a low voltage, it's still going to read a low voltage. No, maybe that doesn't make any sense. I feel like this should work, but it doesn't. No, I may just have to give up and say, well, it didn't work. Which is sad. So what if I just put a button in there? Alright, I give up. It didn't work. So thanks for watching. I'm probably not going to actually post this video. If I do, well, I don't know why. And I'll hopefully get this to work later on. If I am going to post it, it's because I got it to work and I understood why. So thanks for watching. Bye.